This episode is brought to you by Rescue Intelitech, innovating solutions to keep firefighters safe. Their Solo Rescue Decon Washer helps reduce cancer risks by cleaning contaminated gear quickly and effectively. Learn more at rescueintelitech.com because clean gear saves lives. Hi, Chris McClune here with Fire Apparatus and Emergency Equipment. Welcome to this episode of Moving Water. As always, Bill Adkins is here and also Andy Soccodato, two of our advisory board members and FDIC speakers, and this year hot class instructors. So this big busy year for these guys. Andy just recently bought his old Mac pumper, so he's been busy with a lot of things. Still going to get you on to another one, Andy, that we can just talk about that. I talked to Ricky Riley, and he said he's on board with just pretty much the two of you talking about it. But what we're going to do today is something pretty much what we did at the end of the year last year. December came around, and Bill and Andy shared a variety of photos from their year of teaching in various places all around the country. And we're going to do a quick review of those pictures with some of the teaching points. And guys, I'm just going to kind of throw it over to you. I'll interject every once in a while. I'm sure I'll have a question. But this is kind of for you guys. So what I'm going to do is I'm going to share my screen here. Andy, this is the beginning. This is all you. So let's get you started here, and I will turn it over to you. What are we looking at?
Heck yeah. Well, like always, thanks for having us. This last year when we did this episode, I was really excited, and I'm really excited again this year to kind of do this episode to close out the year. So right here is a picture from a conference that we did back in January at the South Carolina Improvement Conference. This is hosted by the South Carolina Firemen's Association, and they put it on every year in January. It's a hands-on conference, and we were teaching the advanced drafting operations portion of their Beyond the Basics pump operator school. So what you see here, we have an engine from the Lugoff Fire Department. Pretty unique engine here. You can see that it has a large cab, three-door cab, because in the back it has like a command post type deal going on there. But what we were doing is we were showing the students the advantages of twin tube drafting. And the water source that we're drafting out of is a large lake that is over at the South Carolina State Fire Academy. And what we initially started the operation with was the driver's side intake. We got that primed, and we have about 15 foot of lift, and their target was to flow about 1,000 gallons a minute. Now, in addition to the 15 foot of lift, they also had some reach issues. We're dealing with, if my memory serves me right, between 50 and 60 feet of hard sleeve to get into the water source. So not only is there lift, there's length that is fighting us. And in order to get to that 1,000 gallon per minute flow, we incorporated the twin tube draft. And you can see that we're doing that by using the officer side intake. And because this truck had a unique cab, normally when we teach this technique, we teach going through the cab as opposed to going underneath the rig to avoid the hot exhaust gases that will potentially melt your hard sleeve and cause all kinds of heartache and pain and just a headache. So obviously, because this rig doesn't have a fourth door, going through the cab wasn't an option. But some quick thinking by the students, they were able to identify a tray next to the crosslays of this pumper that held a Stokes basket. So we removed the Stokes basket. It was a transverse compartment. Removed the Stokes basket. It was the perfect dimension to put a 6-inch hard sleeve through, and we were able to easily twin tube draft in this configuration. So pretty ingenuitive thinking, and on the students' end, we didn't plan that. This engine just kind of showed up that morning, and we were going to have it for the whole conference. So we made it work, and it was really cool to see them thinking outside the box to make that work. One of the things that was really interesting and cool for students to see in this scenario too was when we were flowing 1,000 gallons a minute. What we like to do is we put a vacuum gauge on the test port of the pump intake side of the rig on the vacuum side, and we do that to show students how much vacuum the pump is creating during a drafting operation, just to show how much work the rig is doing. And typically, what most of us teach is that at 22 inches of mercury on your vacuum reading, that's the point where you're kind of maxed out, and if you go much further than that, you're probably going to cavitate the pump. What was really interesting and cool to see here for these students was this class, like I said, was in January, and a couple days before, South Carolina had gotten hit with a snowstorm, and the temperature was very low. Right, it was cold out, and we were dealing with that weather. Well, in order to get to 1,000 gallons a minute through this setup, because of the lift, the distance, and everything like that, the vacuum reading was showing about 24 inches of mercury. And we had talked about, well, at 22, you're going to cavitate, this, that, and the other. It was really good for the students to see that we were able to get to 24 inches of mercury because the water temperature and the outside temperature was so much lower, which meant that the vapor pressure of the water was a lot lower, and it was not going to convert into a gas as what happens during cavitation, meaning we could go a little bit further, create a little bit more of a vacuum before we actually saw that cavitation. And that is something that was unique to the week that we were teaching in South Carolina. We told the students that if they were to come back in July and try and do the same thing, they would cavitate well before 24 inches of mercury and probably wouldn't get that 1,000 gallon per minute flow. So it was really cool for everybody to see that.
With this kind of setup, when you do like a twin tube thing like this, do you set it all up and get both sides connected before you try to get the prime, or do you set one up, prime it, and then you kind of get things started and then go around and hook up the rest of it?
Chris, that is a great question, and it's something that we get asked a lot. So technically speaking, both answers or both ways are correct. You can do
Okay.
it either way. You could set it all up and prime it all at once, and then get it rock and roll and go from there. But what I like to tell people is the difference between this being a cool picture and a parking lot trick and actually doing it in the field is most of the time the fires that I've been to, I don't have the manpower or the equipment to set all of this up at once
Okay.
and then get my prime. So what we like to teach in our classes is we are going to focus on one. We're going to get the first one primed. We're going to get it set up. We're going to get it rocking and rolling. And we're going to start flowing water, even if it is not that 1,000 gallon per minute flow. We're going to start moving water. And then once we get water established, we're going to start gathering the equipment we need to build out that twin tube draft, get it primed, and then continue the operations. And that's exactly what we did in this scenario. The students built the first one out, they got that primed, and once they got that primed and were flowing water out of the deck gun, while they were flowing water out of the deck gun, they were building the second set of hard sleeve for the second intake to show them we're going to start with one, get that rocking and rolling, and then we'll worry about the second.
Does it matter that the the hard sleeve going to the officer's side has at least one extra length on it, probably?
So yeah, technically, if we were to, and again, I've never put flow meters on it to like calculate exactly how much water's moving in each. But technically speaking, if you were to do the math and split everything up, let's say we're flowing 1,000 gallons a minute, right? Well, if both sides are equal length, equal diameter, equal distance, you can assume that 50% of the volume is going to go through this side, 50% is going to go through the other. Because one side is a little bit longer than the other, what is really going to happen is a higher percentage. I can't tell you if that's 60%, 65%, 55%, I don't know. But you could assume that a little bit more of the water is going through the shorter length, and a little bit less of the total flow is going through the longer length. At the end of the day, do you really care about that on the fire ground? I really don't.
Mhm.
But what you're going to see if you're operating this pump is we are going to, if we, let's say originally with the first intake, we're only flowing 500 gallons a minute. When we introduce the second intake, my vacuum reading is going to drop much closer to zero to indicate that I'm not working as hard. Conversely, what I can also do if I want to flow more water, I can flow more water and my intake reading will read back closer to that original vacuum reading.
Okay. Bill, you got anything on this one, or should I move on to yours?
I know, just to reiterate what Andy was saying there, was that's 100 feet of hard sleeve there, not just, that's not 25 and 25. So that's a good distance, and that's a lot of air to overcome. And yeah, it's great setup there.
So, Bill,
All
this
right.
one's yours.
Okay, this is basically this is the nurse tanker system that we set up here at Fayetteville, and we talked a lot about while using a nurse tanker system. If you're using your tank to pump, you're only going to get roughly 750 gallons a minute out of your tank to pump. Instead of like what we do with the roll hitch, where that tanker would eventually disconnect and bring an engine in, we trap our tanker in with a dump tank in behind it, and then we will draft out of that nurse tanker to push that forward to the fire ground so we can get our max flow. If you've listened to a few podcasts before, we talked about this particular tanker, and the new tanker that we had spec'd, they have two tank to pump, so we can get a bigger flow initially out of that tank itself instead of that just 100 or 750. But our setup, while we're using that 3,000 gallon tanker right there to supply the fire ground, we are setting up the tentacles uh, for this to do a draft. So when we draft out of that truck, we can get the full 1,500 GPMs if we wanted to, as long as we have the right intake valve uh, and the strainer, the low profile strainer. You want to make sure you have the right one. So if you're ever trying to draft out of your apparatus and you have a 1,500 GPM pump and you're not getting the numbers that you're wishing that you would get, look at the equipment that you're using. It could be your strainer, or it could be the intake, the valve itself, or if you're using a Storch, you may not get that 1,500 GPMs. But what we do when we set this up is we make sure we use a good strainer, a good intake valve, and then we this truck will sit on the scene, able to supply 1,500 gallons a minute to the fire scene. A lot of departments, when they use a nurse tanker system, all they do is use the tank water, and then they'll use a what we call piggyback. When the next tanker gets there, it will just push its water to the tanker to keep it full. We don't do that because we want to have the ability to supply a larger amounts of water if it's needed. Don't get me wrong, if it's a room and content fire, we can do that. But for those bigger fires, we are going to set that dump tank up so we can get our max flow. And one of the things we talked about in this year on one of our podcasts was getting max flow. How can we get that max flow? How are we able to get a max flow out of a nurse tanker? And that's the drafted itself.
Bill, do you find that because I think I feel like this is a tactic that is really popular in your area. I know it's something that outside of talking to you, I haven't seen a lot of places do committing the tanker, and I personally I love this. I love this tactic. I think it is a great option. Um, but do you find the tanker in this picture is that a 3,000 gallon tanker?
Yes.
Do you find that in a scenario like this, that you don't necessarily have to put as many drop tanks on the ground since you essentially have a 3,000 gallon tank right there in the driveway? So you
Right.
almost have that reserve there as well.
Yes, our goal is once we get there's a second tanker in there in that picture, and it dropped its water. And our first goal was to supply the fire ground, but our second goal was to fill that tank back up. So when we're waiting for more tankers to arrive, we have that 3,000 gallons in that tank as a reserve, and it's just like having a second dump tank down, like what Andy's trying to say there. Now, if your tanker is not set up correctly, it may not work to your, you may have to drop your gallons per minute if you have to shift to your tank water compared to being in a separate dump tank, because we're not drafting at that point. We're using our tank water, which is roughly a 3-inch or a 4-inch tank to pump valve that's gravity fed at 14 psi, and instead of trying to draft that water out of a dump tank where you'll get more flow. So
And Bill, did you obviously it wasn't this rig, but does Fayetteville have another tanker that has, is it a rear mounted pump, or is it just controls at the rear so that way the operator can do everything from the rear in this configuration?
yes, the tanker, you can kind of see behind me sitting there. I don't have a picture with me today of it, but yes, our other tanker has a mid-mount pump like this one
Yep.
here, but I have electronic controls to the rear of the truck so that we can operate the nurse tanker system from the rear of the truck. And the reason I did that is because I like to see my water going into the truck, and instead of having to going back and forth, I can sit there and we don't have, in this picture here, you see, I had to connect 2 sections of hard sleeve just to get to that dump tank, because what we have is what we call a single lane system, so
Mm-hmm.
that tankers can come from both sides of the road. So we usually will set it behind the rig so that nurse tank or the tankers can come and drop it from either way. Um, we don't have to do that with the new tanker because it has a rear inlet, and that takes away the need of that extra hard sleeve.
Yeah, it's one less failure point, right? That
Yeah.
that's great. I really like that. I really like that idea. Do you guys uh how many tankers are you getting in on a dispatch to a rural fire? Like, do you find that if you're doing the nurse tanker operation, since you're committing one to staying at the fire scene, do you feel that it's important, and should viewers understand that if we're doing this, maybe we need to add another tanker if we're doing a route?
Yeah, so if you're planning on that nurse tanker sitting on the scene, you want to count for another tanker to be shuttling. We are fortunate in my area. We live in a farm area, so we're fortunate that our neighboring departments. I have 6. Besides we have 2 3,000 gallon tankers ourselves. Plus, I have 6 3,000 gallon tankers in our neighboring departments that are always readily available. So we're fortunate in that sense. Not everybody
Yeah.
has that capability. And if you don't have that capability and you need that tanker to shuttle, that's where we say to shift to the rural hitch so that
Yeah.
tanker can continue to shuttle.
Awesome.
All right, Andy, take it away.
So this was a photo that we took at a class that we did in Broken Bow, Oklahoma, back in, I think it was February, and we were doing a rural water class for the folks there at a conference. And as you can see here, we are twin tube drafting out of a pond, or excuse me, a lake at a city park for our shuttle operation. And you can see in the back, there's a tanker from the Tom, Oklahoma Fire Department, TOM. Really cool rig. That truck had, if my memory serves right, about 3,000 gallons, but it was a really short wheelbase. The truck was tall, and they built that rig more for wildland and grass scenarios, everything like that. But what was really cool for this Quint here is from Broken Bow, and what we really were trying to show students is, a lot of times people can get in the rural setting, you may not be able to get your quint up at your fire scene because of the size of the apparatus. You may not actually be using a ladder for the aerial device. Well, this is an instance where we can use this quint as a water supply piece. This rig had a 2,000 gallon per minute pump. By assigning it, instead of going to the fire scene, assigning it at our fill site, we are able to take advantage of the big pump, the big motor, and the pumping capacity of this truck. I know it's kind of taboo for folks to think of ladder trucks as pumpers if they, have a pump on them. But in the rural environment, don't discount that. And if you have a quint in your system, it can serve as a water supply piece if it is warranted, and if it's not needed at the fire scene. If you need the ladder truck at the fire scene and it can be used at the fire scene, by all means, send it there. But in this instance, we're simulating a scenario where we don't need an aerial, we need a pump at a fill site. And this ladder truck did a fantastic job. I mean, it was filling tankers at 1,000 gallons a minute all day long, no problem, and no issues here. So,
Would there have been an advantage to going through the cab and going to the other side of the pump versus the front intake, or was this on purpose to demonstrate how well a front intake can do, even though there's usually some friction loss there?
yeah, so that's a great question. So, from a flow perspective, Chris, you're absolutely right. If we had gone through the cab and gone to the officer side intake, we definitely would have gotten a more efficient flow operation for what we were doing. However, really what we wanted to show, and one of the reasons that we elected to set up this way, the picture is kind of hard to tell, but on the officer side of the ladder truck, it's really narrow,
Oh, okay.
and we didn't want to worry about tankers rubbing or anybody trying to get through, because our shuttle route, they would come empty. They would come past the ladder truck,
Oh,
turn around in a turnaround, and then pass the ladder truck again and park where you see the tankers getting filled right there. So
got
we wanted to keep that side as clean as we could and not have to worry about something jutting out and a bad day happening. But the other thing to understand too and remember is the twin tube draft is acting as a redundancy here. And at a fill site, realistically, I'm only expecting this rig to flow 1,000 gallons a minute. You could make the argument that, do I really have to twin tube draft here? You might not have to. I like it as a redundancy, and it also reduces the workload of the pumper. This is a 2,000 gallon per minute pump, but I'm not going to be filling tankers at 2,000 gallons a minute. I'll probably break something if I do, or if I try to do that, right? So that's not advisable. But by using the front intake, really what this is doing is it's allowing the pump to work efficiently. I'm not working the heck out of the pump. But more importantly, you can see in this picture that this lake is nice and clean. But let's say it wasn't. Let's say there was trash or vegetation or something in that pond, right? By having that twin tube draft here, it limits the amount of water that's flowing in each line, so it creates less of a pull or a draw, and you're less likely to clog. I say all that to say that that front intake, while it is probably by itself only good for about 750 gallons a minute, right? It is absolutely okay to use it in this advantage to supplement the driver's side intake that we're using here.
One thing I like to say in a rural setting, if you're not first due, most likely you're not going to get to that fire scene with your apparatus. And if it's not the ladder truck, where normally in the city we leave room for the ladder truck, we don't have that option in these driveways. So just because you didn't show up first doing your ladder truck doesn't mean you can't be useful and dead in the water. So it's great that they were able to use this truck. Most of the ladder trucks in this area have pumps as well. Whether they call them at my department where I work, Lovell and Sims, we call them quints. Here we call them ladder. It's a county type thing, more or less. Still has the ability to pump just as much water as, if not more. Most of our ladder trucks have a bigger pump than the pumpers do. So, yeah, great scene there. This picture here is just showing that you can the floating strainer in this picture is not got a jet siphon attachment. So this department bought an attachment for a jet siphon, and I wish I would have got a better picture of this setup. But that hard sleeve there is 90 feet long, and we were able to jet siphon that water, taking up some of that airspace for that pumper to be able to get that draft. You take a pumper and you're trying to use a primer, and you try to use a prime for 90 inches or 90 feet of air to get that water. It could be a struggle for that primer itself. But by jet siphoning that water towards the truck, it takes away that air in that hard sleeve to make it an easier draft with your apparatus. That's what we're doing with this. So just because you don't have a lot of money, because those floating strainers with a jet siphon adapter are pretty expensive, So this department didn't have a lot of money to spend for that, so they bought this piece here for $300, and they were able to use their hard sleeve up 90 feet away and still be able to get to their water source without having to, for one, get the truck stuck, or buy some expensive piece of equipment to supplement.
What I love about it too, Bill, is right. It's not a one trick pony, right? They could use it to transfer water between dump tanks.
Sure can.
If they were at a dump site. So that's really awesome and great thinking. So this picture here, this is in Greenup County, Kentucky, and we're doing a water supply class, as you can tell. And one of the things that I really liked about this scenario, we have 3 tanks going. This is obviously at the dump site. The Freightliner commercial cab chassis that you see right in front, that is acting as our dump site pumper, and we're simulating that we're pumping through a rural hitch. You can obviously see the tanker that's offloading. A bunch of these tankers in this county are only rear dumping tankers. They don't have any side chutes. So that's why you see we had to get a little creative with how we set up our dump site to stagger our tanks, to be able to set up a single lane operation, but also accommodate the rear dumping tankers for the middle and the third dump tank, the middle tank, and then that yellow tank that's kind of out of frame there. But what was really awesome about this scenario, right in front with the black and orange chevrons, that's a mini pumper that was recently bought by one of the fire departments. It's a Ram 5500 chassis with a 1500 gallon per minute pump on it, and it's a rear mounted pump. But what it was able to do, and it was a great scenario to use this for, we used that mini pumper to back into the primary tank, get its own prime, and that rig became the dedicated transfer pumper. And its job, all it's doing, is powering all the jet siphons that you see for the transfer lines to bring water from tank 3 all the way over to tank 1, and from tank 2 all the way to tank 1. So his job is to pump at 150 pounds and make sure the primary tank stays full. The Freightliner pumper their job is to just deliver the volume needed to the fire scene. So they're worried about pumping water to the attack engine, where the other rig worries about keeping the tank full. So it was pretty cool for these folks to see. They had that unique resource there that is perfect for these kinds of scenarios, a little bit smaller, a little bit more agile, to be able to sneak into these positions and still serve a really important role.
That's yours too, isn't it? Or that's Bill's?
No,
Okay.
No, that's Bill.
Yep. So this is that same department that I mentioned just a few minutes ago. Don't have a whole lot of money to buy the equipment that we've Andy and myself talk about throughout the year. But what they've done is they've created a fast-acting jet siphon that's on their rig. They didn't have the compartment space to put that jet siphon together and in a compartment, so they just simply duct taped it to their hard sleeve, and basically this is an old pickup. This is an old rig. I think it was a 1980. I want to say it was a Pierce, but I'm not 100% sure. But they made it work. This truck functions very well because they set it up. It may not be pretty, but they can quickly take that off the side of the truck, hook it up to their intake, and then they're jet siphoning in just seconds instead of trying to set up the low profile strainer, which you may see at the end of that hard sleeve, and then they just duct tape the hose. Now all they do is they pull that off, break the tape, and they're in business. Just trying to make their rig efficient, not looking. They don't have to be. It's not about how it looks like.
It's
Taking old
it's
rig and
functional.
it it will pump faster than a lot of the new rigs because of the way they have it set up.
That's kind of like a few months ago when we were talking about taking an older rig and making it a water supply rig and equipping it. I mean, this is a pretty good example.
Yep.
So this is in Gainesboro, Virginia, and Wagon 16 that you can see there. That's their brand new Sutphen pumper, and really, this was a great class that we did. Great group of guys in Virginia, right there near the Maryland border, Maryland-West Virginia border in Frederick County, and this rig, like I said, brand new to them that they purchased and they spec'd out. And boy, did these guys do a bang up job spec'ing this rig. This is probably, if I had to, of all the rigs that I see in a year's time, this was probably the best laid out, my favorite rig that I saw all year. They built it to be a true water supply piece and attack piece. So you can see on the driver's side there, they're carrying 30 feet of sleeve right there on the side, on the body. And then on the officer side, they carry another 10-foot section. So the rig's carrying 40 feet of sleeve on it. But you can see that rig is built and set up. It's carrying a lot of sleeve. It has a lot of hose. It has a low hose bed. It has a big pump. It has a big motor. But it has a small footprint. It's still a versatile, maneuverable rig, and these guys did a bang up job building this pumper. But in this scenario here, they wanted to really put it to the test. This was the final scenario we did. We went to a local farmer's pond, and they wanted to see how much water this rig could pump. And we were able to get around 2,200 gallons a minute, somewhere in that ballpark. But they wanted to draft through all 4 intakes at the same time. Not so much because that's something that they think they're going to do all the time. They just wanted to see and test the capabilities of this rig. So what they ended up doing is they built that system systematically, like we talked about. They started with 1 intake. They started with the front, got it primed. Then they moved on to the driver's side intake. You can see here in this picture, they used that dry hydrant. And I don't know if you can tell because I took the picture a little bit further away, but this dry hydrant was hateful. I mean, boy, was it hateful. It was giving us all kinds of problems. We ended up taking some duct tape and saran wrap and went all around it just to get a prime. And, it was really screwing around with us for a good bit. So much so that while they were doing the driver's side, a couple of the students said, hey, you know what, we're going to work on the officer side and get that going. And we ended up getting the officer side primed and built and everything before the driver's side. Eventually, what we ended up doing, because that dry hydrant gave us so much headache, we abandoned it completely, and we added hard sleeve all the way to the water source. So this showed a couple really key important things for the students in the class, but something that I like to talk a lot in my classes as well. Dry hydrants are a great tool, and if you utilize them, that's great. They do save you a lot of work having to put hard sleeve together to reach your source. But if they're not maintained, if you don't inspect them, if you don't test them, they're not worth anything. And you have to be willing and aware enough to recognize when plan A isn't working. Sometimes you need to transition to plan B, right? This dry hydrant probably is giving this homeowner some credit for their insurance and everything like that. That's great. But you can see with a couple of sections of hard sleeve, with the hard sleeve that is carried on this pumper, they don't have to use the dry hydrant if it's being hateful, right? So understanding that just because that dry hydrant is there doesn't mean I have to use it. If it's being hateful, if it's not being cooperative, if it's out of service, go ahead and go directly to the source. You're going to get better water. It may take a little bit more time, but it's going to be a little bit more reliable.
Something I'd like to add to that with the dry hydrants, because we have quite a few out in this area. Before you try to get your draft out of it, we blow it out first. So sediment gets built up into the strainers of those things. All kinds of debris gets clogged in that strainer. So we make a threaded threaded female end to an inch and a half adapter, so that we can blow that out first, and then we will. I'm sorry, it was a male end, 6-inch male end to a inch and a half female end, so that we can blow that out first, not wasting a lot of our water, so that we can then in return connect to the inlet and create that draft. And when you have a dry hydrant that sits out for years at a time and it has been maintenance, like what Andy said, that when they put those together, they use like a pipe dope, what they call it. It's like a what do you call it? A rubber sealant.
Yeah.
And over the years and the weather, that rubber sealant will deteriorate, and then you got pinholes throughout that whole system, and it's very hard to get a draft. So I always keep that saran wrap with me to wrap those dry hydrants if I need them. All right, so we're starting to talk a little bit about some vacuum tankers. This photo is courtesy of Jason Estep out of Morrisville, West Virginia. This is a setup that they were using. What they call they call it suck and dump. So what they're doing is they're using the vacuum tanker, creating that negative pressure, filling the vacuum tanker, and then discharging it into that dump tank behind it. And they can draft that water at 1,000 gallons a minute, and then they cannot dump at the same time. So they will draft it, fill that tank up, and then dump it at between 1,000 and 1,400 gallons a minute, so that second apparatus can then supply the fire scene. If you go to the next picture here, that is over 100 feet away, and you can see how shallow that creek is. Both of those creeks are very shallow. These vacuum tankers are very, very proficient with drafting water. So at 500, an average of 500 gallons a minute at 100 feet away, you can still be able to supply a lot of fire grounds. It's not something that you would use for, this system isn't something you'd use for large fires. We'd still want to do the shuttles. But if you're at a room and content fire or a few rooms of smaller fires, this is a great setup to be able to supply 500 gallons to the fire scene all day long and not have to move your trucks.
So this picture, this is in West Stanley, North Carolina. The scenario here is we have a large pond that is set back from where we can access it. I think it was, if my memory serves me right, between 50 and 75 foot away from where this pumper could actually position. And there was another issue that presented itself to us. Not only was there distance separating us, but the pond itself was extremely silty, very, very silty. So any kind of traditional strainer that we were going to use in there, even if we wanted to do a long reach where we're connecting 80 feet of hard sleeve together, we were really just probably going to end up with strainers that were bogged down in silt and probably going to do a lot of nasty damage to the two pumpers that we were using. One from West Stanley that's out of the picture and one from Concord. So what we elected to do here is we used 2 turbo drafts and we put them in the water. And they sank in the mud a little bit, but the screens were pointing up, so they were able to pull water from above. And essentially, the West Stanley pumper that's not in this picture was pumping the turbo drafts with tank water, and the return line came back to this dump tank and filled the dump tank, kind of like a variation of that suck and dump scenario that Bill just talked about. Then West Stanley's engine got its own prime, and continued the operation to keep this tank full. Concorde's engine then twin tube drafted and got their prime and started flowing out of the tank. So one engine was essentially taking water from the pond that was a distant ways away, bringing it up to the street, where the second engine is able to discharge it to the fire scene or fill tankers or do whatever we need to do with it. And in this scenario, we were able to flow easily over 1,000 gallons a minute through this configuration.
And of course, the bowling pin is there.
Got to have the bowling pin. Yep, that's our mallet.
All right, so this department is the same one that it's called Peebles Fire Department, and it's the same department that I mentioned earlier with the didn't have a whole lot of money. They've created apparatus that's proficient without needing a big budget. So they were able to get a grant, and they actually bought a vacuum tanker. And what they're using this, if you look inside that dump tank, that is a strainer that floats. It also, when it gets to the bottom, it turns into a low profile strainer. There's a few manufacturers out there that makes this, but this one here is well known to be able to draft 1,500 gallons a minute out of that particular low profile strainer slash floating strainer. This department, when they go to put this together, whether it's in a pond or a dump tank, they're using the same strainer every time. I know, like I say, there's a few manufacturers that make these, and I always recommend now, since these have came out, when you buy a strainer, why buy two strainers? You can just buy one. And this one here is I'm not trying to get too much into manufacturers, but this is a Firovac strainer. I know TFT makes them. I'm not sure if anybody else does, but they're out there. If you need compartment space, buy one strainer that does both jobs. So do your homework there, and just like any other strainer we talked about, make sure you do the homework to make sure what it's capable of flowing. But you may see a lot of firefighters will walk up to this dump tank and be like, "Why are you using a floating strainer on this dump tank? Because that's not what you're supposed to use." But this particular strainer, when it gets to the bottom, it becomes a low profile strainer and max flow.
Speaking of strainers,
so talking about strainers and things like that. This looks like a low level strainer, but this is actually called a separator. This is made by a company up in Canada, and it is a really, really cool piece of equipment. Personally, something that has changed my outlook on how to use sources and what is viable, what is not. I actually have an article coming out in a couple months through Fire Apparatus about this. So if you need more information, be sure to check that out. But the way this thing works is, unlike a traditional strainer that basically separates particles from coming in based on the size of the hole or the mesh that is in there, this separator uses separation technology that essentially allows contaminated water with sediment to enter the device, and then it separates the heavier particles from the lighter water and allows clean water to go up to the pump while ejecting the dirty particulate or the silt and the stuff like that out the bottom of the device. So no particulate goes up to the pump. So if I have a really sandy, silty, dirty source, this is something that I can use to protect the pump. And if you actually, go to the manufacturer, their website is protectthepump.com, right? Because that's the intention. But something that is really, really awesome. That's the major advantage of it. And you can see we're in a rocky, silty creek. But something else that is really important and really cool about this device is it is designed to operate in extremely shallow sources. That vegetation guard is just slightly out of the water, but we're not getting any whirlpools. It's not affecting the prime or anything like that. So the water level just needs to be up to that guard. The manufacturer says about 6 inches of depth, okay? So it is able to operate in really shallow sources that I otherwise would have to dam. Okay. And it also allows me to prevent silt and sediment and things like that from actually entering the pump. I was doing a class in Michigan earlier this year, and we had a scenario where we were in a really sandy lake, and I had two different strainers. I had a traditional strainer, and I had the separator here. And we pulled the rig alongside this lake. By using the separator, I was able to get the separator in a sufficient amount of water with 10 feet of sleeve, right? One section of sleeve got me right in, sufficient depth, everything like that. In order to get the traditional strainer in a sufficient depth where it wasn't going to draw silt and sediment and stuff like that, I needed 50 feet of sleeve in order to get it deep enough and far enough away so I had that 2 foot above and 2 foot below. So it really does change the game when I may not have enough hard sleeve to do that. And in shallow sources, right, I can just plop it right in and go to work. So they're really a game changer for those types of scenarios. And you can see it has the jet siphon attachment, so I can do a pressurized prime. The other thing Bill mentioned earlier, why buy two strainers or two pieces of equipment when I could buy one that can do a lot of things? I can use this in a creek here. I can use it in a silty environment. I can use it as my low level strainer out of a dump tank. I can even use it as a jet siphon to transfer water between tanks. So it really does anything I want it to do.
Okay, this picture here is another picture of the what they call a suck and dump. We were, as you guys can see, from what it's straining from, that's actually from flood water. Very, very shallow water. This was down in Parkersville, Ohio, out by Huntington, West Virginia, and we were able to draft out of that vacuum tanker through using flood water to keep our dump tanks full and supply water to the what we were. It was a training, so um, we were simulating a fire scene down the street there.
Is flood water something you would normally want to do? I mean,
There was so much flood water that, now don't get me wrong, the water was dirty. I wish we had one of them separators like when Andy was talking about there. As you guys can see in the drop tanks there, it's pretty muddy water, but that's all from that flood water. But there was enough of it there to where we weren't on the bottom. It's shallow, but not on the bottom of
gotcha.
that little creek there.
So this picture here, this is in Somerville, South Carolina. We were here a couple months ago, and we were presenting our advanced hydrant operations class for the department. And this was during one of the final scenarios. So we offered the class two different times for two different groups. And what was pretty cool is we didn't have the same rigs from Somerville for the entire for the entire class. So the first 2 days we had one rig, and then the second 2 days we had a different engine, and we put both groups through the same scenarios. But what was really cool for the students to see was the difference in plumbing between two rigs within their fire department that were built by the same manufacturers. And in the scenario here, students are tasked with heavy hooking this hydrant and flowing a 2,000 gallon per minute flow. We had already done some other tests. We knew that this hydrant could flow 2,000 gallons a minute. We showed them the advantages of heavy hydrant hookups and all that. And what we're doing here is we're using, when this picture was taken, we're using two sections of pressure rated 6-inch hard sleeve that are going directly into the driver's side intake. And that is allowing that pumper to receive 2,000 gallons a minute, no problem. Now, the first hurdle is getting water into the pump. The second hurdle, once that water's in the pump, you got to get rid of it. And a lot of people are in the mindset of, well, we have 5-inch hose. I can connect this 5-inch hose to my large diameter discharge because my large diameter discharge is designed to pump that 5-inch hose, and I'll be able to get that 2,000 gallons a minute out. Well, the problem there is depending on how the rig is plumbed and what you write in your spec and what you have on the rig, if the plumbing is only going to be so big, so it's only designed to flow so much water. And NFPA 1900 specifies based on the plumbing size how much water a discharge needs to be able to move. So what was pretty cool in this class in particular, the first group, we had a rig that had 4-inch large diameter discharge plumbing. And we were able to get 2,000 gallons a minute out of that 4-inch discharge, but the rig was working pretty hard. It was able to do it, but it was working pretty hard. This rig pictured here has 3-inch plumbing that is feeding the large diameter discharge. So, long story short, that 3-inch discharge plumbing was incapable of getting 2,000 gallons a minute. So it didn't matter that we were getting 2,000 or had the ability to flow 2,000 coming into the rig. The discharge on the outlet side was too small to be able to get rid of it. So what we did and what the students were shown here is in those scenarios, we have to employ something called a parallel supply line operation. So instead of trying to jam all that water through one discharge and one 5-inch supply line, we're going to lay dual 5-inch supply lines and feed it off that pumper. Now, the important thing to understand and note here is in order to feed the second 5-inch supply line, right, it is not recommended to just hook that 5-inch directly to a 2.5-inch discharge because most of our pumpers only have one LDH discharge. So if I hook it to a 2.5-inch discharge, now I'm back into the same problem I had before. I'm trying to jam 20 pounds of crap in a 5-pound bag, and eventually something's going to tear. So what we're doing instead is we're using 3 medium diameter supply lines connected to 2.5-inch discharges on the pump panel going into a gated trimes or tri-gate or whatever you call it. And it is feeding the second 5-inch going to the fire scene. So now I'm splitting the total flow through multiple discharges on the rig, and that minimizes friction within the pump itself and reduces the total amount of work that the pumper is going to have to create in order to move that total volume to the fire scene. So we're actually operating at very low pump pressures, only about 100 pounds on all of those discharges. The engine RPMs are up, but I'm moving a high volume at a low pump discharge pressure, and that's when our pumps are actually most efficient. High volume at low pressures, and that's exactly what we're doing. The way I like to kind of put it all into reference for folks is if you ever do a pump test for a truck, if I have a 2,000 gallon per minute pumper, when I do a pump test, I know that I'm doing it from a draft, and the standard says that I need to use X amount of discharges to X amount of guns to be able to flow that gallon per minute flow. The point is, the pump testing folks, they don't do a 2,000 gallon per minute flow test trying to flow 2,000 GPM out of one discharge. They use multiple discharges during a pump test. So on the fire ground, nothing changes. The physics of hydraulics doesn't change. So if I need to move big water on a fire ground, I need to make use of the multiple discharges that I have on my rig.
With this picture, it's kind of hard to see. I didn't know it was going to come out as small as it did, but what Andy, Chris, and myself have been talking about during this whole podcast is moving a lot of water, and that comes with training. One of my pet peeves is departments that I know that you have a driver's license and you can drive. You're the driver now. You've got to train your firefighters to be able to move that water. And this is what we're doing here. Is you see a firefighter Carnes here. This was his test just a few months ago. He was getting checked off to be an engine operator. And to do that at Loveland Sims, you have to be able to supply an aerial at 1,000 gallons a minute or more, along with using the second stream as their cross lay. And both of them are going to have different pressures and different setups. So we teach those firefighters to how to gate things down and be able to push that water to the aerial device and supply your cross lay. And you have to do the 5 minute drill with the cross lay. Then you get some extra time to hook up to your aerial device, and you have to be able to talk to the other operator and communicate on what pressures they need and make sure that they're getting what they're supposed to have. So my point to this picture here is train, train, train your firefighters. Don't just put them in a seat and say, here, you can pump the truck. And you know, don't just show them how to do tank the pump and the discharge pressure and then hit up aerial. You want to be able to those operators need to be able to function, and sometimes, like what some of the pictures that Andy showed, they need to be able to create something. They have to think outside the box to create some things. Not every time you're going to be 90% of your fires is going to be done with one line, you know, and a hydrant per se. But you'll have those instances where you need to create something, and what are you going to do? What are they going to be able to do to make that happen? Train your firefighters to be able to think outside the box.
Yeah, and Bill, like you said, that's the difference between a pump operator and a lever puller, right? They're
Yeah.
perishable skills, and you need to constantly hone them in order to be a true operator. All right, so this picture here, this is in Benton Harbor, Michigan. We were there just a month or two ago, and this rig is pretty unique. It looks like your typical, run-of-the-mill engine company, but this rig actually has underneath the cab, it has a Ford Power Stroke motor. Okay, so it's the same 6.7 motor that is in your pickup trucks, right? And the reason, don't quote me, I'm not 100% sure on the exact number. Pierce did a limited number of these when they were released. So it's rather unique to come across one and not only get to see one, but actually pump one. So what we were doing in this scenario, this is our advanced hydrant operations class. And this hydrant here is a 2,000 gallon per minute capable hydrant. And the class wanted to see just how much of that water this small block motor is going to be able to get rid of. So we already knew it was 2,000 gallon per minute capable, and we were able to achieve 2,000 GPM with engine 54. Now it was working, all right. It was working pretty hard. The pump is rated at 1,500 gallons per minute. Um, but under the right circumstances, heavy hydrant hookup on a strong water supply, that doesn't mean that it is incapable of flowing that 2,000 gallon per minute flow. Now, it was maxed out on its engine RPM, so we hit the governed speed of the motor, but this smaller power plant was capable of moving that hydrant's capacity, which was pretty cool to see. And then the next picture is a older 90s model Pierce that had a 60 series Detroit in it. And the major difference once we had engine 54 up there, we replaced it with this pumper and did the same evolution. We were able to flow the same 2,000 gallons a minute out of this 1,500 gallon per minute pumper, but the major difference was this 60 series Detroit wasn't working near as hard as the other motor. So it does all matter. And, just understand that the power plant is something that is very critical to the overall operation of your engine. Obviously, that the bigger the motor, that comes with the price tag, but those are all things that apparatus committees have to weigh. And sometimes it's out of our control. The point that we're trying to make here is, even if you have a smaller rig, using the right setups with your hydrants and receiving water correctly with the proper techniques and using the right intake valves and everything that we've talked about so far, you can get big water into the pump and therefore potentially get rid of it, even if you have a smaller motor. So, we kind of hit it on the last couple of slides, but get out there and train and actually see what you're capable of doing, right? You got to know your equipment. You got to know your equipment and find where those limitations are.
Guys, thank you very much for doing this. I when we did this last year, it was a big hit. I mean, people really seemed to like it, and really what I liked about today was just we really went pretty broad. We had some hydrant operations, we had some rural operations. We got into simple things like how to use what you've got to think outside the box when you need to, and of course what's become very critical these days is setting up a truck, setting it up well, and doing it on a limited budget. So thank you both very much for doing this. We've got a new year starting next month, and we're always planning our future topics here. But if you have something that you'd like us to talk about on Moving Water, please let me know. I'm at chris.mcclune@clarionevents.com. We also have all of our podcasts, whether it's Moving Water or any of the other ones. They are all archived at www.fireapparatus.com/podcasts. So, guys, thank you very much for doing that again. It takes a little bit of time picking out all those pictures. So thank you very much for doing that.
Yeah.
Like I said, we're gonna keep this up next year. If there are any topics, please let us know. But until then, have a good one, everyone. Thanks, guys, and stay safe.
Thanks for having us.
Thank you.